Good afternoon. We are into chapter 15 of structure of atoms and nuclei. So we are into this chapter, which is structure of atoms and nuclei. And in our earlier lecture, we have covered everything detail about the different models of atom, where we discussed the Thomson model. Then we discussed Rutherford model. Then after that, we discussed the postulates and the other details of the Bohr's atomic structure. After that, we completed the hydrogen spectra. Under this topic, we discussed about the series like Lyman, Balmer, Paschen, Brackett, and Pfund. We have discussed all these series, their needed details in full respect. Today we will take our syllabus to the next level in the chapter where we need to talk about radioactivity, in which more emphasis will be there on the half-life period. So let's begin with the topic of radioactivity. Now, the phenomena of radiating the radiations or particle from a nucleus is called radioactivity. So radioactivity, we can say that it's a phenomena in which a particle or energy is emitted out from nucleus. So one thing to be more noted here is that this phenomena is at nucleus level. No orbital electrons, they are playing the role in this. Now we know that every atom is represented by help of or with the help of its atomic number and its mass number. So we know Z is its atomic number. Mass number is given by A. So this is mass number or atomic mass number. This atomic number, they're as simple as number of protons, whereas mass number is same as number of protons plus neutrons. Sometimes we call them nucleons. Now, this adjustment for the number of proton and the number of neutron is being done in such a way that whatever is the positive charge because of the nucleus is having a correct balance with a negative charge that is created by these orbiting electrons. If there is a mismatch in that, then in order to become stable, this nucleus opts a method of radioactivity. That means in order to have a balance with the orbiting electrons, this nucleus changes its structure accordingly to have that balance. What are the different possible ways that we are going to see it in next part? But let us say that if we zoom into the nucleus, we find out that nucleus is made up of numbers of protons and neutrons. If we zoom inside a neutron, if we zoom inside a neutron, we will find out that one neutron is again a combination of proton plus electron. And hence, the net charge onto neutron is 0. It's neutral. But when we say that it is a neutral, it doesn't mean that it is not having any charge. Rather, we can say that it is having equal amount of positive and negative charge, and that's what we call it proton plus electron. Together, it makes a neutron. In this way, the nucleus is constructed. Now starts the working part. Wherever any nucleus decides to adjust its structure in order to be having a stable or to have a stability, there are three different ways to attain the stability. First one is to emit beta particle. Second one is to emit gamma. Third one is to emit alpha, of which beta and alpha, they are particles. They are particles, whereas gamma is a strictly radiation. Alpha, again, particle. So what exactly is done in case of beta particle? Let's consider onto that. Let us say that we do have this nucleus, and this nucleus is finding a little imbalance to counterpart these electrons. So the nucleus takes its own decision for having the stability. One of that is to emit beta particle. Let us say that we have one nucleus in which there are two protons and let us say two neutrons. And somehow this nucleus finds that it has to increase its positive charge to counterbalance the electron cloud surrounding it. Now what it does, it actually breaks this proton. As it breaks the proton, it gets two particles here. One is it breaks neutron and it breaks a neutron and it gets a particle like proton and electron. This electron is thrown out of this nucleus, and whatever this electron which is thrown out from the nucleus from this neutron, this particle we call it beta particle. Now what's the effect of that? Earlier we had two proton and two neutron. Now what we have, three proton and only one neutron. So what has happened to the net positive charge of this nucleus? Gets increased. Result of that, there is a possibility that this nucleus now can counterfeit these negatively charged electron and the atom becomes the stable. But in this process, what has happened is, if we say that we have a material X with atomic number Z and mass number A, we find out that when it emits beta, which is one electron, so it's a -1, the atomic number of this material, it becomes Z plus 1, whereas surprisingly, mass number remains the same. There is no change in mass number because mass number is a number of nucleons, number of protons per plus neutron. So earlier it was 2 proton plus 2 neutron, 4. Now it is 3 proton plus 1 neutron, again 4. So there is no change in atomic number, but what has changed, there is no change in the atomic mass number, but what has changed is its atomic number. This is one of the method that opted by an atom to attain the stability. Then the second method that atom may apply for or may opt for is of division, which is we simply call it as fission. Now what happens in this case? Suppose if we say that we do have a atom nucleus which is having number of protons and neutrons compactly fitted in this space like this, which is generating instability, which is giving it the state of non-stable. So it's not because of the amount of charge, or it's not because of the number of protons, but it is because of the high density compaction. Under such situation, this nucleus decides to divide itself into two parts. What it does is that from its existing structure, it separates out a nuclei which has two proton and two neutron. Now we know what is this is helium nucleus or helium nucleus. Why helium nucleus is selected is because helium is the first inert gas element. It is the first element, the smallest sized element, which is stable, highly stable. So the nucleus takes care that whatever partition is done, that partition is done in such a way that whatever separated out nucleus, it should not have any other side effect onto this main nucleus, as it is stable. So it selected the helium part. Now in this case, what has happened? That suppose if we say that we do have a material like X, Z to A, which emits alpha. Now we know what is alpha is a helium nucleus. So I can say that 2 and 4. Result of that, in order to balance the equation, I have to say that it will result in a material which has got atomic number subtracted by 2 and the mass number subtracted by 4. So we get these two equations. The third method is a very peculiar one, in which case we find out that absolutely compacted nucleus, when decides that it has to adjust with the electron cloud and the liberation of alpha or liberation of beta particle is not serving the purpose, then in that case, what it does, it's just reorientation of nucleons to increase its size. Like the nucleus, now it may be become like this with protons and neutrons. They are situated properly inside the nucleus. Under this condition, when these protons and neutrons internuclear distance is increased, it's like nucleus is a little bit relaxing itself. In that process, whatever is the energy that is liberated out, that energy is in terms of gamma radiation. And in this way, any nucleus will always try to become stable by opting a method of radioactivity in which it will either emit alpha, beta, or gamma, depending upon the best suit method to attain the stability.